Write polynomial equations and functions when given solutions and zeros. There are a few pointers. First, if k is a zero of a polynomial function f, then the following three apply. First, we have that x minus k is a factor of the polynomial f of x. Second, k is a solution, also known as a root, of the equation f of x equals 0. So if we set f of x equal to 0 and we solve for it, we will get the solution k. There might be multiple solutions as well. And then third, if k is a real number, then when you graph f, k will be an x-intercept on the graph, and you will actually be able to see it. All right, let's try an example. Write a polynomial equation whose solutions, roots, are 7 and -1. All right, so first, I'm going to write what the solutions are. X equals 7 and x equals -1. Now, based on what I talked about earlier, up here, if 7 is a solution, then x minus 7 will be a factor. So that is what I have there. And notice that I set it equal to 0 because we want an equation. Okay, we're looking for an equation. All right, I went ahead and did the next part. So x minus -1 becomes x plus 1. And now we just have to distribute. So we have x times x is x squared. X times 1 is 1x. -7 times x is -7x. And then -7 times 1 gives us -7. We combine the middle terms and we get our final answer. So our equation is x squared minus 6x minus 7 equals 0. And if we solve that, we are going to get the solution 7, -1. And you could solve it with your choice. You could solve it by factoring. You can solve it by completing the square, quadratic formula, graphing, technology, whichever. You will get the solutions 7 and -1. I think also let's sketch f of x equals that. And here's my coordinate plane. It's going to be a sketch, so it doesn't have to look perfect, but I know it hits 7 and -1, so it looks something like this. Okay, looks something like that. It's a sketch, and I decided to do a little bit of a better job there. So there's this nicer parabola, and you know I can mark a few points here because I know that this is -1. This other x-intercept is 7, so we're just showing that this is also true. And we know the y-intercept is -7. I could also mark that, but there it is. Just keep in mind that if you're asked for an equation, it should be set equal to 0, like you see there. And if you're asked for a function, well, if we're asked for a function, you should have, you know, f of x equals that expression, or just y. Next, we will write a polynomial function. That's key, that it's a function whose zeros are 7, -1, and 1/2. Also worth remembering is that the leading coefficient has to be 4. All right, so I'm going to start with what the zeros are. The zeros are x equals 7, x equals -1, and x equals 1/2. Leading coefficient's 4. If 7 is a 0, then the factor will be x minus that value, x minus 7. X minus -1/2, x minus 1/2. If we do all that, that'll give us a leading coefficient of 1. So to make it a leading coefficient of 4, we just multiply the entire thing by 4. So that's where that 4 comes from. So now we just have to multiply things out. So x minus -1 is x plus 1, and we multiplied that in an earlier example, so I know that that part, this part here, gives me There's trinomial. Now I'm going to rearrange things. So think of the associative property of multiplication. I think it's easier if we multiply 4 times the factor of x minus 1/2. Because when I distribute that, I will get 4x minus 2. So 4x minus 2, now I have to multiply it by the trinomial, and when all that gets multiplied out, you can do that on your own to show the work, you get f of x equals 4x cubed minus 26x squared minus 16x plus 14. And notice that at the front of that is f of x because, like we mentioned earlier, we want it to be a function. If we look at the graph for this, I use Desmos. I use Desmos to graph our answer, and our answer is the one that I will highlight right now, and it is shown on the graph by a solid line. The graph next to it in a dashed line in orange is if I didn't multiply by 4. As you notice, you would still have the same x-intercepts. Still the same x-intercepts here. However, the graph will not follow the same shape because when you multiply everything by 4, you get that vertical stretch. So the graph that we want is the one in the solid line. So just note that if you don't multiply by whatever the leading coefficient should be, you would still have the same zeros. However, it is not the same graph. We can also check if our answer is correct by using synthetic substitution. So I will do that next. So I will take the coefficients, and you notice everything there is already in standard form. There's nothing missing, so I don't have to put in any zero placeholders. And I'm just going to go in order. I'm going to substitute 7. So 7 is going to get substituted. Remember, bring down the 4. So putting that arrow helps you do that. So you will have 4 down there. 7 times 4 is 28. Negative 26 plus 28 gives me 2. 7 times 2 is 14. Add those up, you get negative 2. And 7 times negative 2 is negative 14. And we get a 0. And that is what we want. So that is good. Checks off. Now we can continue with the numbers we have left, 4, 2, and negative 2, and substitute the next values. So the next value is negative 1. Remember, arrow. So negative 1 times 4 is negative 4. Add those up, gives you negative 2. And negative 1 times negative 2 gives us positive 2. Then combine those and we get 0. So that's good. And then the last number left to check is 1/2. Okay, same thing as before, bring down the 4. 1/2 times 4 gives me 2, and then negative 2 plus 2, I get 0. So that confirms all my zeros worked out, and I'm left with a 4 at the beginning, but that just represents the leading coefficient. And in its current state, that would be like the constant. So what we just did is confirm that our function has the 0, 7, negative 1, and 1/2. We confirmed that with graphing. We confirmed it with synthetic substitution. So we can be confident in our answer. Make sure you circle it.